And this is taking your Walmart data and doing what we call inferential statistics. So that means everything in this assignment is either going to be a confidence interval or a hypothesis test. If this is all mixed up between the confidence intervals we did in the last unit, where we just had one sample, there's some of that in here, and there's also some two sample stuff. So there's also some stuff from what we're doing this week. So you kind of have to figure out which one is which. The main thing to remember in this is that everything that we're talking about in this project has to do with the means. We're always talking about the mean salaries or the average salaries. So anything you do in StatCrunch is going to be done with the t-stats. You're not going to use anything else for this project. I mean, not for the inferential statistics part. You're either going to be doing t-stats with one sample or t-stats with two samples or t-stats paired. One of those three things for this entire assignment. So the first thing on here is to do the confidence intervals. So the first thing I have you do is decide what confidence level you're going to use. And this is going to be for all of the confidence level, all of the confidence intervals in this assignment. So you can choose anything between 90 and 99%, but you need to explain why you're choosing that. Keep in mind that for this project, that the end goal is that you're going to come up with something that you could supposedly present to a jury as evidence for one side or the other. So think about if you were a juror sitting on the jury for this case, how confident would you want to hear that the person was that was presenting this information? What confidence level would you want them to have in what they're telling you? You can't have a confidence level of 100%, so that won't work. But anyway, you can choose anything between 90 and 99%. And then just put down what level you're going to use and then explain why you chose that. So just tell me what your reasoning was for choosing that level. Then after that, once you've decided on your confidence level, then it's going to tell you to do some different confidence intervals. And this is where you have to figure out which one of those things it's asking for. Whether you're doing the t-stats with one sample or with two samples or with paired. There should be enough clues in the explanations for you to figure that out. If you're doing confidence intervals in StatCrunch, I'm just opening a random data set. If I want to do a confidence interval for the mean of the wait times, then I'm going to do t-stats. And for this, right now I'm just going to do one sample. So I'm just going to take this whole thing together and just do a confidence interval for all of this data together. So I'm just picking my thing here and I'm choosing confidence interval. This is why I said you're going to use t-stats for everything in this assignment, because you can choose to do a hypothesis test or you can choose to do a confidence interval. And then just put your confidence level in here. And then what it gives you is the lower limit and the upper limit. So these two answers are what you're looking for as far as what your confidence interval is. This would be saying that the wait times are between 5.2 and 5.5 minutes. That would be your confidence interval. If we look at a different data set, you might also be able to do something with paired data, which they'll be doing on some of these for the Walmart data. So here's one that actually was from some study about IQ scores for siblings and whether they were related or not. So in this one, they took two kids from the same family, so a younger sibling and an older sibling, and looked at their IQ scores. So this was paired data. So if we wanted to do something about the mean of the IQ scores, this would be, if we're talking about paired data, that means we're looking at the difference in their IQ scores and doing a confidence interval or whatever for that. So for this, I would do t-stats and paired. And then I just have to tell it what I want my first sample to be and what I want my second sample to be. So I chose sample 1 was the younger sibling and sample 2 was the older sibling. And then I'm going to do a confidence interval. And this is giving me a lower limit and an upper limit again. These are the values for the differences in the IQ scores. So this is saying my lower limit is -6.3 That means that if I looked at a younger sibling and an older sibling, the difference in their IQ scores, the lowest that could go would be a negative 6.3. That would mean that the younger sibling had a lower score than the older sibling, because when I subtracted them, I got a negative number. But then my upper limit is a positive number, so that's a positive 0.2. That would mean that the younger sibling's score was actually higher than the older siblings, because when I subtracted them, I got a positive number. So when you do things with paired data, it's really important to see whether 0 is in the interval or not. So like in this one, 0 is in the interval because I've got one negative limit for my lower limit and my upper limit is positive. If 0 is in the interval, that means that technically the two scores could be the same. So the younger and older siblings got the same scores. So what this would tell me is that there's not a significant difference in the scores for the younger and the older siblings. I think you had a homework problem this week that had something to do with that, whether 0 was in the interval or not. But that's when you're looking at paired data. And actually for this, there's a question about how much to round the answers to. Actually, you can round these to the nearest dollar. But because of the way the data is, it's already rounded to the nearest, I don't know, $100. So you could round it to the nearest dollar. The one we were looking at a minute ago, with the paired one where it did include the 0, that meant that that wasn't statistically significant. That's hard to say. So on the other hand, if it doesn't include 0, so for example, if they're both negative or if they're both positive, then that means there is a statistically significant difference. So this one, there is not a significant difference, but if this upper limit was also negative, then there would be a significant difference. When you get to where you're writing the confidence interval statement, when you get to the ones where you're doing the difference, now I just put this statement in here as an example. The data that I gave you, the female was the first column and the male was the second column. So a lot of you are doing your confidence interval so the female came first. If you did it that way, so when your StatCrunch results, if it says female minus male, then really when you do your confidence interval statement, you should put female first so that it matches. So on this statement, instead of saying the differences between male and female managers' salaries, you should say between female and male managers' salaries. Because otherwise, anybody reading it would think that it had come out the other way. So whatever you did in StatCrunch, make sure that it matches. So the order that you did in StatCrunch, make sure that the order in your statement matches that. So one of the big ideas in this whole project is that we've got two different sides of the case. We've got one side that says that basically the salaries are about the same. There's not a significant difference. We've got another side that says there is a significant difference. So the results you're going to get by doing the different things you're doing are going to come out on both sides of that. So you might have one result that says there's not a significant difference. You might have another one that says there is. That's how it's supposed to turn out. So when you get to the hypothesis test, again, you have to make really sure of which thing you're doing, whether it's independent samples or dependent samples. That's why it asks you specifically which one it is. So when you're doing that, make sure that you know which one you're supposed to be doing. It asks you to do 2 hypothesis tests. You should be doing 2 different things. So you should be doing one that's independent samples and one that's dependent or paired samples. The other thing you have to make sure of with this is when you go to write your alternative hypothesis, so when you go to put the inequality in StatCrunch, make sure that, again, that it matches what order you're doing things in. So if you have the females first, then, for example, for this claim right here, if you're talking about if you have the females first in your StatCrunch data, then you might want to take this claim and turn it around because this one has the males first. Either that or when you do it in StatCrunch, do it so the males are first. So you have to make the 2 things match. If you were going to turn this around and put the females first, then you'd want to say the mean pay of the female managers is lower than the mean pay of the male managers. So just make it match with what you've got in StatCrunch and how you're doing your claim. And if it comes out, if your hypothesis test results come out looking really weird, then that's might be what happened, is that you didn't have those two things matching up. And if you're trying to figure out whether it's the two sample or the paired, the one that's paired is a little bit more obvious. I mean, it has some things stated in there that make it a little bit more obvious that it's paired. So you might just want to look at both of them, and it might be easier to pick out which one is paired, and then that means the other one is the independent samples. Yeah, so this is another one where you need to save the file. So put all the StatCrunch results and stuff in there, save the file, and then attach it in the blog. One more hint on which one of these is paired and which one of these is the two sample. When you do your tests in StatCrunch, if I'm doing a two sample, one, then down here for my hypothesis, it actually has two different means. So it has the mu1 and the mu2. So the two sample one is the one with the two different means. If I'm doing a paired one, then when I do it, then in my hypothesis right here, it only shows one mean. It's the mean of the differences. So paired means there's only one mean. Two sample means there's two means. So if you look at your claim, that's another way that you can kind of determine which one of those is which. So if it talks about two different means, then it's a two sample test.